In this question, we're given a cylinder that represents a can, and we're asked to find how many times larger is the volume of a can if it has triple the radius, but it has the same height. Well, let's visualize the problem first. I'm going to outline the cylinder here, and then we'll move it over and we'll make it the smaller cylinder. And this can has a radius of 4 centimeters and a height of 10. Now let's draw a can that has triple the radius and the same height. Well, if it has triple the radius, then the radius here would be 12 centimeters. And if it has the same height, then the height would be 10 centimeters. And what we have to do is figure out how much more volume does this can hold, than this can. Well, there's a couple of ways that we can do it. The first way I'm going to show you here is to compare the volumes of the two cans as a ratio. So the volume of the larger can will equal pi r of the radius of the larger can squared times the height. And the volume of the smaller can will equal pi, the radius of the smaller can squared, times the height. So let's compare these two volumes. Well, we know that pi is the same for both, so we can eliminate that in the division. We know the height is the same for both, so we can eliminate that from the division. So what we can say is the volume of the larger cylinder is to the volume of the smaller cylinder as the radius of the larger cylinder squared is to the radius of the smaller cylinder squared. Well, we know the radius of the larger can is 12, so we can replace this here with 12 squared. And we know the radius of the smaller can is 4, so we can replace that with 4 squared. And what 12 squared means is 12 times 12. And what 4 squared means is 4 times 4. So 4 goes into there once and goes into 12 3 times. 4 goes into there once and goes into there 3 times. So the top is 3 times 3 or 9, and the bottom is 1 times 1 or 1. So what this means is the volume of the large can to the small can is 9 to 1. Or in other words, the larger can is 9 times larger. The volume is 9 times larger than the smaller can. So if we look down our list of options, it looks like B is the right answer. If we weren't sure about working out the solution using ratios, we could just simply find the volume of each of the cans and divide them to see how much larger this can is than this can. And that might be a good way to verify that we've got the right answer. So let's start again. And for the volume of the cylinder, and we'll look at the large volume first, it's pi r squared h. And we know that pi is 3.14. And we know the radius of the large can is 12, so that would be squared, and we know the height is 10. And when we multiply that all out, 3.14 times 12 times 12 times 10 gives us 4,521.6. And again, don't forget the units. These would be centimeters cubed. Now let's work out the volume of the smaller can. So again, the volume of a cylinder is pi r squared h. We know that pi is 3.14. The radius of the smaller can is 4, so 4 squared, and the height is the same at 10 centimeters. And when we multiply that out, 3.14 times 4 times 4 times 10 gives us 502.4, and again the unit's centimeter cubed. And just to make sure, volume is a three-dimensional measurement, so we have to have our units in a degree of 3. So let's see how much bigger this number is than this number. We simply divide the two. So 4,521.6 centimeters cubed divided by 502.4 centimeters cubed. And the centimeters would cancel, would just give us 9. So there we go. We verified that our answer is indeed correct using a different method.